Hello students, welcome to this lecture One Circles. So in this lecture we will discuss NCERT exam plus problem one circle. Okay, so let us solve this first one. So in first one here we have, if radii of two concentric circles are 4 centimeter and 5 centimeter, then length of each chord of one circle which is tangent to the other circle is what? So we need to find the length of length of each chord of one circle which is tangent to the other circle. Okay, so first of all draw the figure. So here C1 and C2, they are concentric circles, and here they have center O. Okay, and here we let the O be the center of two concentric circles C1 and C2, and choose radii R1 is equal to 4 centimeter and R2 is equal to 5 centimeter. So now we draw a chord. So now we draw a chord here AC of circle C2, which is touches the circle C1 at point B, and also join OB, which is perpendicular to AC. Tangent at any point of circle is perpendicular to radius through the point of contact, through the point of contact. So now in right angle triangle OBC, by using Pythagoras theorem, here in this triangle OBC, here OC square, this is equal to BC square plus BO square, and here OC is equal to 5 centimeter, and BO, this is equal to 4 centimeter. Since we have given the radii R1 is equal to 4 centimeter, okay, and R2 is equal to 5 centimeter. So therefore this radius OC is radius of C2, and here OC is equal to 5 centimeter, and OB, this is the radius of C1 circle, and this is equal to 4 centimeter. Okay, so from this triangle OC square is equal to OB square plus BC square, and here OC is 5 and OB is 4, then BC square, from this equation we will get BC square. So it implies 5B square, this is equal to 5BC square plus 4 square. Since we know by Pythagoras theorem, hypotenuse square, this is equal to base square plus perpendicular square. So from this from this equation, BC square, this is equal to 25 minus 16, and this is equal to 9, and it implies BC is equal to 3 centimeter. Okay, so BC is equal to 3 centimeter. So therefore length of the chord AC, this is equal to 2 times length of BC, that is equal to 2 times 3, and this is equal to 6 centimeter. Okay, so the length of the chord AC of circle C1, which is tangent to the circle C2, so circle C1 C2, the chord of the circle C2 which is tangent to the circle C1 is 6 centimeter. Okay, so here the option number B is correct answer. Now let us see next question. So in next question, here we have this figure. So in figure, if angle AOB, this is equal to 125 degree, then we need to find angle COD is equal to what? So in this problem, we have given this angle OAB, this is equal to 125 degree, and we need to find angle COD. Okay, so basically we need to find this angle. So let us see how to find the angle COD. So we know that the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. Okay, that is angle AOB plus angle COD. This is equal to 180 degree. Okay, and here we given angle AOB, this is equal to 125 degree. So therefore angle COD, this is equal to 180 degree minus angle AOB, that is equal to 180 degree minus 125 degree, that is equal to 55 degree. Okay, so the angle COD, this is equal to 55 degree, and here option number D is correct answer. Okay, so here the correct answer is option number D. Now let us move to next question. So in next question here we have, in figure AB is a chord of circle and AOC is its diameter such that angle ACB, this is 50 degree, and if AT is the tangent to the circle at the point A, then angle BAT is what? So we need to find angle BAT. So let us find. So in figure, AOC is a diameter of the circle, and we know that diameter subtends an angle 90 degree at the center. Okay, we know this. We know this. So angle ABC, this is equal to 90 degree, and angle A plus angle B plus angle C, this is equal to 180 degree. And in triangle ACB, in this triangle ACB, here, since sum of all angles of a triangle is 180 degree, and in this triangle ACB, angle A plus 90 degree plus 50 degree, this is equal to 180 degree. Okay, and it implies angle A plus 140, this is equal to 180 degree, and it implies angle A is equal to 180 degree minus 140 degree, that is equal to 40 degree. Okay, so angle A, this is equal to 40 degree. And now AT, this is tangent to the circle at point A. So OA is perpendicular. OA, this is perpendicular to the tangent AT. So angle OAT, this is equal to 90 degree. And here angle OAB plus angle BAT, this is equal to 90 degree. Okay, and when putting angle OAB is 40 degree, then we get angle BAT. This is equal to 90 degree minus 40 degree, that is equal to 50 degree. Okay, so this angle BAT, this angle is 50 degree. So here the correct answer is option number C. Now let us move to next question. So in next question here we have, from a point P which is at a distance of 13 centimeter from the center 0 of a circle of radius 5 centimeter, the pair of tangents PQ and PR to the circle is drawn. Then the area of the quadrilateral PQOR is what? Okay, so let us see how to solve this problem. So firstly, draw a circle of radius 5 centimeter having center O, and P is a point at a distance 13 centimeter. Okay, from O, and a pair of tangents PQ and PR are drawn here. So thus the quadrilateral PQOR, this quadrilateral is formed, and here OQ, this is perpendicular to PQ or QP, since AP is since this is QP is a tangent. Okay, and OQ is radius. So we know radius is perpendicular to tangent. Okay, so in right angle triangle OQP or right angle triangle PQO, here OP square plus OP square, this is equal to OQ square plus QP square, and here OP is equal to 13 centimeter and OQ is equal to 5 centimeter. So it implies 13 square plus 13 square is equal to 5 square plus QP square. Okay, and it implies QP square is equal to 169 minus 25, that is equal to 144. Okay, and therefore QP is equal to 12 centimeter. So now area of this triangle is equal to 1 by 2 times 12 times 5, that is equal to 30 centimeter. Okay, so area of this triangle is equal to 30 centimeters, and now we need to find the area of this triangle, and then if we add the area of this triangle and area of this triangle, then we get the area of this quadrilateral. Okay, and here actually in option A we have the value 60 centimeter square. Okay, the area of the coordinator PQOR is 60 centimeter. So here the correct answer is option number A. Now let us see next problem. So in next problem, here we have at one end A of a diameter AB of a circle of radius 5 centimeter, tangent XAY is drawn to the circle. The length of the chord CD parallel to XY and at a distance 8 centimeter from A is what? So let us see how to solve this problem. First of all, draw the figure. Okay, so first draw a circle of radius 5 centimeter having center O and a tangent XY is drawn at point A. Okay, so a chord CD is drawn which is parallel to XY and at a distance of 8 centimeter. Now angle OAY, this is 90 degree since tangent and any point of a circle is any radius passing through at the point of contact is perpendicular to radius through the point of contact. Okay, so it implies triangle AOY plus the angle AOY plus angle OED. This is equal to 180 degree and angle OED is equal to 180 degree. Now in right angle triangle OEC, A is equal to 8 centimeter, A is equal to 8 centimeter and join OC, then OC square is equal to OE square plus EC square, and it is by Pythagoras theorem. Okay, so EC square is equal to OC square minus OC square, OC square minus OE square, and this is equal to 5 square minus 3 square. Since OC is radius, that is equal to 5 centimeter, and OE, this is equal to AE minus AO, that is equal to 8 minus 5, that is equal to 3 centimeter. Okay, and EC, this is equal to 4 centimeter, hence the length of the chord CD is equal to 2 times CE, that is equal to 2 times 4, that is equal to 8 centimeter. Okay, so the length of the chord is 8 centimeters. So here the correct answer is option number D. So now let us move to next question. So in next question, here we have this figure AT is a tangent to the circle with center O such that OT, this is 4 centimeter, and angle OTA, this is equal to 30 degree. Then AT is equal to what? So let us find. So join OA, and here OA is perpendicular to AT. So angle OAT is 90 degree. And in this triangle OAT, here cos 30 degree is equal to AT divided by OT. 80 divided by OT, and this implies root 3 by 2 is equal to 80 by 4, and it implies 80 is equal to 2 times root 3 centimeter. So 80 is equal to 2 times root 3 centimeter. Now let us move to next problem. So in next problem, here we have in figure, if O is the center of the circle and PQ is a chord and the tangent PR at point P makes an angle of 50 degree with PQ, then angle POQ is equal to what? So let us solve this problem. So here given that angle QPR, this is equal to 50 degree, and we know that the tangent at any point of a circle is perpendicular to the radius through the point of contact, and therefore this angle OPR, this is equal to 90 degree. Okay, and it implies angle OPQ plus angle QPR, this is equal to 90 degree, and it implies angle OPQ is equal to 90 degree minus 50 degree, and this is equal to 40 degree, since angle QPR, this is equal to 50 degree. So now OP is equal to OQ, they are radius of circle, and since angle OQP is equal to angle OPQ, that are 40 degree. Okay, so in triangle OPQ, since angle opposite to the angle sides are equal, And since sum of angles of a triangle is 180 degree, so it implies angle O plus angle P plus angle Q, this is equal to 180 degree. Okay, and it implies angle O is equal to 180 degree minus angle P minus angle Q, and here angle P equal to 40 degree, this is equal to angle Q. So angle O, this is equal to 180 degree minus 40 degree plus 40 degree, that is equal to 180 degree minus 80 degree, and this is equal to 100 degree. Okay, so the angle POQ, this is equal to 100 degree. So here the option number A is correct answer. Let us solve the next problem. So in next problem, here we have in figure PA and PV, if they are tangents to the circle with center O, such that angle APB, this is equal to 50 degree, and then angle OAB is what? So let us solve this problem. So here given PA and PV are tangents line, and here PA is equal to PB. Since the length of tangents drawn from an external point to a circle is equal, okay, so it implies angle PVA, this is equal to angle PAB is equal to theta. And in triangle PAB, here angle P plus angle A plus angle B, this is equal to 180 degree, since sum of angles of a triangle is 180 degree. And here angle P is 50 degree. So, and here angle A and angle B are equal, and we say here angle A is equal to angle B is equal to theta. So it implies 50 degree plus theta is equal to 180 degree. And it implies 2 theta is equal to 180 degree minus 50 degree, that is equal to 130 degree, and it implies theta is equal to 65 degree. Okay, so also here OA, this is perpendicular to PA, and OB is perpendicular to PB. So since tangent at any point of a circle is perpendicular to the radius through the point of contact, so therefore angle PAO, this is equal to 90 degree, and it implies angle PAO plus angle PAO is equal to 90 degree, and here angle PAB is 65 degree, so it implies 65 degree plus angle BAO is equal to 90 degree. So it implies angle BAO is equal to 90 degree minus 65 degree, that is equal to 25 degree. Okay, so angle BAO is equal to 25 degree. And now let us move to next problem. So in next problem, here we have, if two tangents incline at an angle 60 degree are drawn to a circle of radius 3 centimeter, then the length of each tangent is what? Okay, so let us solve this problem. So first of all, draw the figure. Okay, so let P be an external point here, and a pair of tangents is drawn from the point P, and angle between these two tangents is 60 degree. So PA and PC, they are tangents of this circle. So join OA and OC. Join OA and OP, and also OP is a basically bisector of the bisector line of angle APC. So therefore angle APO, angle CPO is equal to 30 degree, and also OA is perpendicular to PAP. Okay, in right angle triangle OAP, here tan 30 degree is equal to OA by AP. Okay, and here OA is 3 centimeter, so tan 30 degree is equal to 3 by AP, and here tan 30 degree is equal to 1 by root 3, so it implies 1 by root 3 is equal to 3 by AP, and it implies AP is equal to 3 times root 3 centimeter. So AP is equal to 3 times root 3 centimeter. So it implies 1 by root 3 is equal to 3 by AP, and hence the length of each tangent is 3 times root 3 centimeter. Okay, so the length of each tangent is 3 times root 3 centimeter, and here the correct answer is option number D. And now let us move to next problem. So in next problem, here we have in figure in this figure, if PQR is tangent to a circle at Q, whose center is O. AB is a chord parallel to the tangent PR, and angle BQR, this is equal to 70 degree, then angle AQB is equal to what? Okay, so let us find. So given here AB, this is parallel to PR, and therefore angle ABQ, this is equal to angle BQR. Okay, and they are 70 degree. They are actually alternate angles. And also QD is perpendicular to the chord AB, and QD bisects AB. So in triangle ADQ or QDA and triangle QDB, here angle QDA, this is equal to angle QDB, each 90 degree, and here AD is equal to BD, since QD bisects the chord AB, and here QD is equal to QD, their common side. So therefore triangle ADQ is congruent to triangle BDQ by side angle side similarity criteria. So then angle QAD, this is equal to angle QBD. Also angle ABQ, this is equal to angle BQR, and therefore angle ABQ is equal to 70 degree, and angle QAB is equal to 70 degree. Now in triangle ABQ, here angle A plus angle B plus angle Q is equal to 180 degree, and it implies angle Q is equal to 180 degree minus 70 degree plus 70 degree, that is equal to 40 degree. Okay, so the angle AQB is equal to 40 degree. So here the correct answer is option number B. And now let us move to next problem. So in next problem, that actually very short answer type questions. So if first one, here we have, if a chord AB subtends an angle of 60 degree at the center of circle, then angle between the tangents at A and B is also 60 degree. Okay, so let us check. Since a chord AB subtends an angle of 60 degree at the center of a circle, that is angle AOB, this is equal to 60 degree. As OA is equal to OB, radius of the circle, and therefore angle OAB, this is equal to angle OBA, and this is equal to 60 degree. And the tangents at point A and B is drawn, which intersects at point C, and we know OA is perpendicular to AC. So OA, this is perpendicular to AC. Okay, and here now, and OB is perpendicular to BC. So angle OAC, this is equal to 90 degree, and angle OBC, this is also equal to 90 degree. So it implies angle OAB plus angle BAC, OAB plus angle BOC, BAC is equal to 90 degree. So it implies and angle OBA plus angle ABC is equal to 90 degree. So it implies angle BAC, this is equal to 90 degree minus 60 degree, that is equal to 30 degree, and angle ABC, this is equal to 90 degree minus 60 degree, that is equal to 30 degree. So in triangle ABC, in this triangle ABC, here angle BAC plus angle CBA plus angle ACB is equal to 180 degree. Okay, so it implies angle ACB, this is equal to 180 degree minus 30 degree plus 30 degree, that is equal to 120 degree. Okay, so the angle ACB, this angle is equal to 120 degree. Okay, so 120 degree, but here we have given, if a chord AB subtends an angle of 60 degree at the center of a circle, then angle between the tangents at A, and B is also 60 degree. Okay, so this statement is a false statement. So now let us move to next problem. So in next problem, here we have the statement: the length of tangents from an external point P when a circle is always greater than the radius of the circle. Okay, so let us check whether this statement is true or false. So because the length of tangents from an external point P on a circle may or may not be greater than the radius of the circle. Okay, so the given statement is a false statement. And let us move to next problem. So in next problem, here we have the length of tangents from an external point P on a circle with center O is always less than OP. Okay, so let us check. So here PT, this is perpendicular to this is tangent drawn from external point P and join OT. Here OT is perpendicular to PT, so OPT is a right angle triangle form. Okay, so in right angle triangle, OTP OPT hypotenuse is always greater than any of the two sides of the triangle. Okay, so where OP this is greater than PT and PT is less than OP. Okay, so the length of tangents from an external point P on a circle with center O is always less than OP. Okay, is always less than OP. So the statement given to us in question number 3 is true statement. Now let us move to next problem. So in next problem, here we have the tangents between the angle between two tangents to a circle may be 0 degree. So let us check, is this true? This may be possible only when both tangent lines coincide or are parallel to each other. Okay, that case the angle between two tangents to a circle may be 0 degree. So the given statement is a true statement. And now let us move to next problem. So in next problem, here we have, if angle between two tangents drawn from a point P to a circle of radius A and center O is 90 degree, then OP is equal to A times root 2. Okay, so let us check. So here this is true statement. From the point P, two tangents are drawn, and here given OT, that is radius. Okay, so what is A, and also line OP bisects the angle RPT. Also in triangle OTP, here the angle TPO TPO, this is equal to angle RPO. Okay, and this is equal to 45 degree. So here OT is perpendicular to PT, and it implies 1 by root 2 is equal to A by OP, and this implies OP is equal to A times root 3. Okay, so OP is equal to A times root 3. So if angle between two tangents drawn from a point P to a circle, if of radius A and center O is 90 degree, then OP is equal to A times root 2. Okay, so the given statement in question number 5 is a true statement. And now let us move to next problem. So in next problem, here we have, if angle between two tangents drawn from a point P to a circle of radius A and center is O is 60 degree, then OP is A times root 3. So let us check. So from point P, two tangents are drawn. Here given OT is A and OR is also A. So also line OP bisects the angle RPT, and therefore angle TPO and angle RPO, this is equal to 30 degree. Also OT is perpendicular to PT, so this angle is 90 degree. So OTP, this is actually right angle triangle, and here sine 30 degree is equal to OT by OP, and it implies 1 by 2 is equal to A by OP, and it implies OP is equal to 2A. So but here OP is A times root 3, so the given statement is a false statement. Okay, so this statement is a false statement. So I stop here this lecture. Thank you very much to all of you.